3.3, work, energy, and power. Here we're going to be talking about the relationship that the potential energy at the top of an object's path is equal to the kinetic energy at the bottom of an object's path. So this is a huge idea, but this idea helps us to do a lot of mathematical relationships. Okay, so let's read the following question. A 75 kilogram skateboarder rolls across a frictionless horizontal surface at 10 meters per second. Part A, if the skateboarder were to roll up a ramp at this speed, what is the maximum height the skateboarder would reach before rolling back down? So let's work on part A only. 75 kilograms. It's a frictionless horizontal surface at 10 meters per second. If they were to roll up this ramp at the speed, what is the maximum height? So that's the key word, maximum height. That's what they want us to find. So let's list out our givens. So we have mass is 75 kilograms. So if you were wondering what does that picture actually look like, think of it as a ball, right? So this person is on some flat horizontal surface, and then they're asking, well, what happens if the ball is up here? You know, what would be this height value? Okay, so they say the velocity is 10 meters per second. My unknown is h. So now my equation, well, now we got to think about my energy values. We know that all my energy at the top of an object's path is solely and purely potential energy. There is absolutely no kinetic energy. However, we know that as my ball or whatever gets closer to the ground, that potential energy is being converted into kinetic energy. We're not losing any mechanical energy overall. And that when the object is at the bottom of its path, we know that its KE is the max value. Okay, so at the top, we say that PE is max. At the bottom, we say that kinetic energy is at its max value. So whether we're at the top or the bottom, we are solely one type of energy. At the top, we are only potential. At the bottom, we are solely kinetic. Okay? So now let's write out our following relationship. We said that PE top equals KE bottom. But if we write out this statement, that really doesn't help us actually do anything. So what we really need to be writing out is the following. The formula for potential energy is mgh, and that's equal to the formula of kinetic energy, which is 1/2 mv squared. Both of these formulas can be found in your reference table. So now what we're going to do is plug in our values. So my mass is 75 kilograms. So again, we come across this G. We're on Earth, so that's 9.81 meters per second squared. Our height is the thing we don't know. Now we go over to the equal sign. 1/2. Again, my mass is 75 kilograms. My velocity is 10 meters per second. And don't forget that's squared. Again, that's the most common mistake. So now let's clean some stuff up. Let's clean this whole side up right here. Okay? So if I plug this into my calculator and I do 1/2 times 75 times 10 squared, I would get a value of 3,750. And then let's clean up this right here. So 75 times 9.81, that's 735.75. Just drop down the h. The h is held together with that number through multiplication, so we do division to undo the multiplication. So my height value for part A, so if I do 3,750 divided by 735.75, I would get a height value of 5.09, which is also equal to 5.1. We use the unit of meters to measure height or distance, okay? So h equals 5.1 meters. If you were to keep it as 5.09, you would not be wrong. We don't do significant figures in physics, only chemistry does that. So here you can round to whatever you want, but you should at least keep either one or two places after the decimal point. So that was just for part A. So now let us do part B. Okay, so if I'm going to reread the question. So it says, and I'll highlight in a different color. So it says, again, a 75 kilogram skateboarder rolls up a frictionless horizontal surface at 10 meters per second. Part B says, how fast was the skateboarder moving when he reached a height of 2 meters? Okay, so it says how fast. Well, what that means is the following. So our givens are still going to be the same. The only given that it will change is we're not using the height that we calculated. They actually give us a height right here. So everything else still stays the same though. So we know that my mass is still going to be 75 kilograms. we know that my velocity, or excuse me, we don't know the velocity because it says how fast. So we know that the height is now, I believe it said 2 meters. Yep, 2 meters. Our unknown, right, it says how fast. That's the velocity that we're looking for. So my equation, so again, it's still this this idea that all the energy at the top, which is solely potential energy, is going to equal all the kinetic energy at the bottom. So PE top equals KE bottom. We know that just writing this idea isn't going to just help us solve anything. So the better way to write it would be to write out the formulas for potential energy and kinetic energy and set them equal to each other. So we write mgh equals 1/2 mv squared. Then we're going to substitute. So my mass is still going to be 75 kilograms. Again, we're on Earth, so we use that nice special value of 9.81. Remember, do not put the minus sign in because energy is a scalar value, so it cannot be negative. It would make absolutely no sense to say I have negative 30 joules of energy. That has absolutely no meaning. It makes no sense. My height this time is 2 meters, equal to, let's see, 1/2. My mass is still going to be the same. Notice that mass is on both sides of the equation, and mass is a value that won't change. I leave my v squared, so let's clean up. Oops. Oh, no. Oh, no, sorry, guys. There's no undo button here. Oh, yeah, there was, actually. I lied. No, there isn't. Undo, redo. All right, well, I guess I'll have to rewrite that. So I have 2 meters equals 1/2, 75 kilograms, and then v squared. Okay, so let's take care of this. My apologies. 75 times 9.81 times 2. And we get a value of 1,471.5. We equal that to, let's see, 1/2 times 75. That is 37.5 v squared. So now we have to figure out what we need to do from here. So v squared is held together with 37.5 through multiplication. We do division on both sides. So we divide both sides by 37.5. So we're left with v squared is equal to the following. 1,471.5 divided by 37.5. You should get an answer of 39.24. We don't have our answer yet because we have the square. So in order to get rid of a square, we have to square root both sides because that takes care of the square, and we're left with velocity of the following. 6.26 meters per second. Okay? So pretty simple. Just make sure this is so important, but it's more important mathematically. However, you can't just use that statement mathematically. You actually have to write out these formulas right here. And if you set them equal to each other, you will never have an issue. As long as you make sure that both sides of the equal sign are equal, you're saying that total mechanical energy is conserved. When you write PE top equals KE bottom, okay? So very similar to our law of conservation of momentum. But other than that, it's pretty simple. Just set both formulas equal to each other and solve for the missing variable. You're either going to have a velocity missing or you're going to have height missing, because mass will always be given since it's on both sides of the equation. And G, you know, because you live on Earth.